Okay, we're going to learn about the law of sines today, but before we do that, we're going to talk about triangles and how we can label them. The law of sines and the law of cosines that we're going to learn about in just a bit are all about working and solving triangles that are oblique. And what do we mean by oblique? They're triangles that don't have a right angle, triangles that are not right. They don't have a 90-degree angle. So we're going to use the law of sines in this case to help solve triangles. But before we do that, we need to learn how to draw and then label an oblique triangle. Okay, so if I call this, suppose, angle A, and I call this angle B, and this angle C, then I need to label the opposite side of the angle with the corresponding side. So if this is angle A, then this one right here is side A. If this is angle B, then this one right here is side B. If this is angle C, then the opposite here is side C. And notice I use capital letters for the angles, lowercase letters for the side lengths. Okay. Now, in general, there are 4 triangle congruencies. There's the angle, side angle, or side angle, angle. We know, in this case, 2 angles and a side. There's the side, side angle, which for obvious reasons is not the angle, side, side. So in the side, side angle, you're given 2 sides and then an angle. There's the side angle side, where you know 2 sides and an angle, but the angle's in between. And then there's the side, 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 which you know all 3 side lengths, but you don't know the angles. So if you think about it, this is what we're going to be investigating when we look at the law of sines. So let's go ahead and take a look at an example of the law of sines, and then we're going to see how it applies. So first thing to do is review what the law is. Okay, so here's the law for us. All right. The law of sines, it says in any triangle ABC with sides length A, B, and C, all lowercase, A over sine A equals B over sine B equals C over sine C. Now you're only going to be using them in pairs. You know, A over sine A equals B over sine B, or B over sine B equals C over sine C. You're not going to be using all 3 at once, okay? That's not necessary. All right. Now, I'm going to tell you that this version of the formula is good when you are trying to find a side length, okay? But if you're trying to find an angle, you can reverse it, okay? So for example, if you're trying to find a missing angle, then you can say, well, sine A over A equals sine of B over B equals sine of C over C. So this right here is a good way to find those angles if necessary. Okay, give me 1 second. I'm having a few little computer issues. Okay, so let's take a look at an example here. It says a satellite orbiting the Earth passes directly overhead at an observation station in Phoenix and Los Angeles, which are 340 miles apart. At an instant when the satellite is in between these 2 stations, its angle of elevation is simultaneously observed to be 60 degrees at Phoenix and 75 degrees at Los Angeles. How far is the satellite from Los Angeles? So what I'm going to do, I'm going to use this triangle. First thing I'm going to do is draw this satellite out in space. All right, there's my satellite. Looks more like a bow tie. There's my satellite S. Okay, now Los Angeles is west of Phoenix, so I'm going to put LA here and a P for Phoenix there. All right, now I'm going to label my angles, of course. Call this one angle A, call this one angle B, and call this one angle C. Okay, and then I'm going to label my side lengths. Call this side A, call this side B, call this side C. So the question is, how far is the satellite from Los Angeles? So they're asking us in this case, well, if they want to know how far is the satellite from Los Angeles, they're asking us to find this side length C. Okay, so that's what it is that we're solving for. Now they give us a bit of information. They tell us that the angle of elevation observed is 60 degrees at Phoenix. So I'm going to put 60 degrees there. And at Los Angeles, it's 75 degrees there. Now, this, if we want to finish filling this in, well, we remember that any triangle is 180 degrees, right? So you add 75 and 60, and you subtract that from 180, and you will get 45 degrees. So we have 45 degrees there. So that's a 45 degree angle. Whether or not we need it, I don't know. What else do we need to know? Phoenix and LA are 340 miles apart. So that's this right here, 340 miles. Okay, so let's see. We are looking for a side length. So if we're looking for a side length, we're going to use this version of the formula. And what else do we know? We know the angle B. Well, actually, we know the side B. So we know we're going to use B over sine B. Okay, and then we're looking for side C, so we've got to use this as well. So this is the version of the formula we're going to look at. We're going to say B over the sine of B equals C over the sine of C. Okay, and it's going to look just like that. So if we're looking for side C, what we've got to do here is we've got to isolate little c, and we're going to multiply both sides by the sine of c, like this. So then we get a formula that looks like sine of little c over, times side b over sine of little b, and that should equal our side length c. Okay, and actually this is sine of c and this is sine of b. Sorry about that for the confusion. So then we're going to type in on our calculator the sine of 60 degrees, because c, angle c, is right here, 60 degrees. All right. And then we're going to multiply that by the little b, which is 340 miles. And we're going to divide that by the sine of 45 degrees. And this will be our side length c. And if you plug all of that into the calculator, you find that the satellite is 416 miles from Los Angeles. So there's our answer, 416 miles right there. Okay, so that's one application of the law of sines. Now we're going to take a look at a special case of the law of sines, and that is to look at this one right here, the area formula. This is a special area formula based on the law of sines relation. So we're going to take a look at it, but the important thing to note is what information are you given so that you can match what you know to the formulas. So we're just going to basically apply one of these formulas, but let's see what we know. We know angle A, we know side B and side C. So let's see which formula that is. I see an angle A, I see side B, side C. So this is the formula right here that I'm going to use. And these are very easy questions to find the area of a triangle. You don't even need to draw the triangle in this case. So what does the area look like? It is half of BC times the sine of the angle A. So in this case, we have half of 11.1 times 6.6 times the sine of 39.2 degrees. So it's very important that your calculator is in degree mode when you're doing this. And you're going to get 23.2 inches squared, because the units are inches, and of course area is always square units. So this is the answer, and how you would go about finding the area of a triangle with a special application of the law of sines. So I hope this video was helpful, and always remember, if you like this video, give it a thumbs up, and don't forget to like and subscribe.